You may remember from somewhere in your algebra past the idea of composition of a function with its inverse. So composition of functions is when I nest them one inside the other. If I want to do f of f inverse of x, or if I want to compose them the other direction with f inverse on the outside, f inverse of f of x, I get the same thing either way, and what I get is just the x that I started with. The idea is my function does something to x, and its inverse undoes it, and I end up just with x. And this is the way composition of a function with its inverse works in general. It's also the way composition of a trig function works with its inverse trig function. With caution, we have to watch out for domain and range issues. For example, if I want to find the arcsine of the sine of pi over 5. Well, I don't know the sine of pi over 5. Pi over 5 is an angle in quadrant 1. I could find its sine value. I guess I could do it on a calculator if I really wanted to know. And I'll get some positive number between 0 and 1. And then I want to take the arcsine of that value. Well, when I take the arcsine of that value, the range of the arcsine function is quadrant 1, which is where pi over 5 is. So if I do the composition of the inverse sine function with the sine function for this pi over 5 that's in quadrant 1, I'm going to just get back pi over 5. And I never actually have to find out what the sine of pi over 5 is. I don't care. I'm going to recognize the composition of a function with its inverse and be able to evaluate. Similar idea, if I want the cosine of the arc cosine of, let's say, negative 3/5. Well, the arc cosine of negative 3/5 is the angle whose cosine value is negative 3/5. And that's somewhere in quadrant 2, because the range of the arc cosine function is in quadrants 1 and 2, so this is an angle in quadrant 2. I don't know what it is, but that's okay. If I take the cosine of that angle, guess what I'm going to get? I'm going to get negative 3/5, same that I started off with. Composition of a trig function with its inverse trig function. But suppose I want the cosine, actually I'm going to do the arc cosine of the cosine of 7 pi over 6. Your first instinct might be to say, I got an inverse cosine composed with a cosine. Those are inverse functions. They undo each other. And I'm going to get 7 pi over 6. The problem is 7 pi over 6 is not in the range of the inverse cosine function. So it can't be 7 pi over 6. The inverse cosine function only has values between 0 and pi. So let's go back to the drawing board, as it were, on that one. I want the inverse cosine of the cosine of 7 pi over 6. Well, I know the cosine of 7 pi over 6. Cosine of 7 pi over 6, that's in quadrant 3. Cosine values are negative, so that's negative root 3 over 2. The inverse cosine of negative root 3 over 2 is an angle in quadrant 2, because that's the part of the range of the arc cosine function where my cosine values are negative. In quadrant 2, with a reference angle of pi over 6, we're going to get 5 pi over 6, an angle in quadrant 2, not an angle in quadrant 3. So this, we have to use a little bit of caution here. Suppose I want the arctangent of the tangent of 3 pi over 4. Same problem here. The range of the arctangent function is quadrants 1 and 4. minus pi over 2 to plus pi over 2. 3 pi over 4 is not in that range. So when I evaluate this, I can't possibly get 3 pi over 4 because it's not in the range of the arctangent function. But what I do want is the angle that's in, this will be in quadrant 4, where my tangent values are negative, that has the same tangent value as 3 pi over 4, and that is negative pi over 4.